This question is actually outlined in problem 14 in the chapter on methods of differentiation, but let's have a look at it anyway. To do this one, we have to recognize that tan x equals sine x over cos x, and you'll always be given the relevant trigonometric identities on the paper with the correct formulae shown, so you don't expect it to remember that. So now we're going to differentiate this. What's the differential of sine x over cos x? We have to use the quotient rule to do that, where we would let the top be u and the bottom be v. And the quotient rule tells us that the differential of y with respect to x equals the bottom function multiplied by the differential of the top minus the top multiplied by the differential of the bottom all over the bottom function squared. So if we apply that to this, we let u equal sine x, so therefore du by dx is cos x. We let v equal cos x, so therefore dv by dx equals minus sine x. And now we plug these into this formula, so dy by dx, or d by dx of tan x, equals v, which is the bottom function, times the differential of the top function, which is cos x, minus the top function, which is u, which is sine x, times the differential of the bottom function, which is minus sine x, all over the bottom function squared, which is cos squared x. Rearranging this and simplifying, cos x times cos x gives cos squared x. Minus times a minus gives plus sine squared x all over cos squared x. And then again, this formula would be on the equation sheet, but you need to recognize that sine squared a plus cos squared a equals 1 is a trigonometric identity that we can use. And if we recognize that, we know that the top all can be written as 1. So the differential is 1 over cos squared x. And again, if we recognize that 1 over the cosine is the secant, which is another trigonometric identity which, if you needed it, would appear on the exam sheet, we can write that dy by dx equals sec squared x.